Hello everyone. Now we have to discuss the conditions for reciprocity and symmetry for all parameters. Okay. First we have to discuss those conditions for z parameters, later y parameters, followed by h and t parameters. So what is reciprocity? Already we have discussed this concept in network theorems, right? Reciprocity means what? The ratio of response to the excitation is equal even though the positions of the response and excitations in the network are interchanged. You can get the same value of response to excitation ratio. If the ratio is same in both the cases, obviously that circuit is under reciprocity. Like that, what is symmetry? A two-port network is said to be symmetrical if the input and output ports can be interchanged without altering the port voltages and currents. Even though the positions of the input and output ports are interchanged, the values of voltage and currents are not changed, remain same. Then only it's said to be symmetrical. Okay. First we have to write what is reciprocity. The ratio of excitation, response, right? Ratio of excitation, the ratio of response to the excitation is same if the positions of response and excitations are interchanged. This is about reciprocity. What about symmetrical? Symmetry. What is symmetry? The input and output or you can write if the input and the output ports can be interchanged without altering the port voltages and current. That's it. If the input and the output ports can be interchanged without altering the port voltage and currents, then only we can say the circuit will exist in symmetrical condition. That's it. This is reciprocity, symmetry. Now we have to get the conditions for reciprocity and symmetry in Z parameters. Okay, first I would like to derive condition for reciprocity. Okay. To get reciprocity, how many cases we have? We all know that two cases. Case 1, for that, what is the circuit? What is the circuit model? Output port, input port, right? The output port should be short circuited. In between input port we have voltage, we have a current, but here what we have, the current is what? Now we can consider the current direction as what, like this, minus I2. The actual direction is what? I2. Here V2 is equals to 0, short circuited. From this we can get ratio of response to the excitation, which is equals to what? Excitation is what? Minus, or simply we can write I2 by V1. Okay. Now we have to get from this model, we can get I2 by V1. Okay. Later from case 2 we can get short circuit this input port, open circuit this output port. From that we can get I1 by V2. If both are equal, this circuit exists reciprocity condition, otherwise not. Okay. From this we can get I2 by V1. So here V2 is equals to 0. When V2 is equals to 0, what are the equations? V2 is equals to 0 means what? We have V1 is equals to Z11 I1, like that. V2 is equals to 0, which is equals to 0. Sorry, you can write Z12 I2, which is equals to Z21 I1 plus Z22 I2, right? So from this V2 is equals to 0. Sorry, I2 is minus I2. You can write minus I2. Finally, we have to get I2 by V1. So from this, we can get I2 by V1. We can get the value of I1. Then we can substitute that value of I1 into this equation. Okay. So from this, Z21 I1, which is equals to Z22 I2, right? From this I1, which is equals to what? Z22 by Z21 into I2. Now we can substitute this equation into this equation, right? Therefore V1, which is equals to, now this is the equation, right? V1 equals to what? Z11. In place of I1 we have Z22 by Z21 I2 minus Z12 I2. From this V1 is what? Z11 Z22 minus Z12 Z21 by Z21. This is I2. So from this we can get I2 by V1 is what? I2 by V1, that is Z21 by Z11 Z22 minus Z12 Z21. We can say that Z21 by delta Z. What is this delta Z, sir? Where delta Z is nothing but Z11 Z22 minus Z12 Z21. So this is from case 1, ratio of excitation. So response to excitation is what? Z21 by delta Z. Now we can get second case. case 2. Now we have to short circuit input port. Right? This is the actual current direction through this port 1. Now we can consider minus I1, right? Across we have V2, this is I2. We all know that this is V1 is equal to 0. When V1 equals to 0, what are the equation? V is equals to I into Z, which is equals to V1, which is equals to 0, which is equals to Z11 I1 plus Z12 I2. Like that, V2 is there, some value, finite value, that is Z21 I1 plus Z22 I2. Here I1 is negative value, right? That's it. From this, we have to get what? Ratio of excitation, that is I1 by V2. We have to get I1 by V2. That's it. Required, right? From this case 2, we have to get response to excitation I1 by V2. There from the first case we have what? I2 by V1. From this I1 by V2. So to get I1, we have to get the equation in terms of only I1 and V2. Therefore we have to replace the current I2, right? So this is 0. From this Z11 I1, which is equals to Z12 I2. Therefore from this I2 is equals to what? Z1 by Z11 Z12 I2. So we can substitute this value into this equation. Therefore finally what we have? V2 is equals to Z21, or you can write my I1 plus Z22. In place of I2 you have to substitute Z11 by Z12 into I1, right? Therefore V2, which is equals to what? Z11 Z22 minus Z12 Z21 into I1 by Z21, sorry, Z12. Z12. From this, I1 by V2 is nothing but what? From this I1 by V2, which is equals to what? Z12 by Z11 Z22 minus Z12 Z21. So from this I1 by V2, which is equals to Z12 by delta Z, right? This is what? Equation 2. Therefore, what is the reciprocity condition? By reciprocity condition, the ratio of response to excitation from the first case, that is V2 is equals to 0. Therefore I2 by V1, which is equals to I1 by V2, right? Then only we can satisfy the reciprocity condition. So I2 by V1 is nothing but, from the first case, Z21 by delta Z, right? This is what? Z21 by delta Z, which is equals to, what is I1 by V2 from the second case? Z12 by delta Z. So from this one gets cancelled. Therefore we have what? Z21, which is equals to Z12. This is the condition for condition for reciprocity, that is Z21 mutual impedances are equal. Right? Next we have to get symmetrical symmetry, condition to get symmetry. Right? For that applying common voltage, let us say voltage V at input port and keeping the output port open, and keeping the output port open. Right? From this what we are having, keeping the output port open, I2 is equals to 0. Therefore V1 which is equals to Z11 I1 only. Right? So not V1, it is only V, because we are providing only V. Right? From this applying voltage V at output port and keeping open circuit at input port. Applying voltage V at output port and keeping the input port open. From this V is equals to output port, right? V is equals to Z22 I2, right? You can write that is I2 is equals to 0, that is I1 which is equals to 0. From this Z11 is what? V by I1. From this Z22 is what? V by I2, right? Next we can write the condition of symmetry is observed is observed only when V by I1 should be equals to V by I2, which means what? V by I1 and V by I2 is nothing but what? V by I1 is nothing but is equals to Z22. So this is the condition of condition for symmetry, that is self impedances are equal, right? So summary. Condition for reciprocity, condition for symmetry in case of Z parameters. What is the condition? Mutual impedances are equal. Condition for symmetry, Z11 is equal to Z22, that is self impedances are equal. So simple. To get reciprocity, first we have to short circuit output port. We can get I1 by V2. Second case, next we have to short circuit input port, that is I2 by V1. That's it. Then we can get the condition of reciprocity. Like that, to get symmetry, we have to provide equal voltage by open circuit second port from the first case, like that open circuit second case from the second port. Then we can get the condition for symmetry. That's all for reciprocity and symmetry for Z parameters.